Something separates the senior engineer whose terminal sessions produce results in the time that junior developers spend figuring out where to start, whose debugging sessions resolve in minutes the problems whose investigation junior developers conduct for hours through the sequential one command at a time approach that the absence of specific knowledge produces when the knowledge whose possession would transform the investigation from a sequential process into a parallel, comprehensive, immediate one is the knowledge that nobody in the organizational hierarchy above them has communicated in the terms that would make its immediate adoption possible, rather than leaving its discovery to the accidental exposure pathway that produces it for some developers through the specific circumstances of working with the right person at the right moment on the right problem, and for many developers, never, because the accidental exposure pathway, whose operation depends on the coincidence of proximity and problem and conversation partner, is a knowledge distribution mechanism whose failure rate across the developer population is high enough that the knowledge it distributes to the developers whose circumstances include the necessary coincidences represents a systematic advantage over the developers whose circumstances do not include those coincidences, whose absence from their experience is not a reflection of their capability or their diligence, but of the knowledge distribution failure that the absence of explicit teaching about specific high-leverage technical capabilities produces when the educational pathway through which most developers acquire their Linux knowledge covers the foundational capabilities thoroughly and the highest leverage advanced capabilities barely or not at all something that is not the abstract. Superiority of experience, whose communication in explicit technical terms would eliminate most of the performance gap that experience produces. Something that is not the result of superior intelligence, whose possession produces the discovery of advanced capabilities that average intelligence would not discover, but the knowledge of a specific command whose existence, whose complete capability scope, and whose application to the daily engineering workflows that every Linux developer and systems engineer performs produces the transformation from the slow, incomplete, multi-command investigation approach to the fast, comprehensive, single-command approach that the senior engineers, whose terminal fluency junior developers observe and admire, are producing through the specific knowledge that this examination is about to communicate in the terms that make its immediate application possible. Stop everything. This one Linux command that senior engineers use daily has not been taught to you. And the specific character of what not being taught means, in this context, requires the distinction that separates the knowledge that the educational pathway provides and the knowledge that the educational pathway does not provide, whose boundary falls in the specific place where the foundational Linux education that most developers receive stops, and the high leverage advanced capability knowledge that most developers discover only through the accidental exposure pathway begins. A boundary whose location in the knowledge landscape this examination is precisely identifying by pointing at the specific command on the advanced side of that boundary, whose location there produces the performance gap between developers who know about it and developers who do not. That the command's daily use by senior engineers and non-use by junior developers creates. The command is not obscure in the sense of a rarely needed specialized tool whose mastery serves the narrow use cases of a small population of engineers with unusual workloads. It is the command that senior engineers who have been using Linux professionally for 5 or more years reach for routinely in the daily work of diagnosing system problems, investigating application, behavior, understanding what their systems are doing, and making the debugging decisions whose quality determines how quickly production problems are resolved and how thoroughly development environment issues are understood before the developer, whose understanding of their environment is based on partial information, makes the decisions that partial information produces. Its non-teaching to developers earlier in their career is the non-teaching that produces the years of slower debugging, less complete. System understanding and more sequential investigation, whose accumulated productivity cost represents an enormous career-level productivity loss, whose cause is the absence of one command from the educational pathway, rather than the absence of the intelligence or the dedication that the performance gap's existence might otherwise suggest. The urgency in this title is the urgency of the developer who is currently conducting the sequential investigation that the command would transform into a simultaneous one, who is currently running the sequence of separate commands whose individual outputs each answer one question about the system state that the single command this examination is about to describe answers all at once in the unified output whose comprehensiveness produces the complete picture that the sequential investigation's accumulation of partial answers eventually approaches but never achieves, with the simultaneity that makes the complete picture available at the moment of investigation rather than at the end of the investigation sequence. Every hour that passes before you learn this command is an hour during which your debugging sessions are longer, your system investigations are less complete, And your understanding of what your Linux system is actually doing is more partial than it would be if the command whose communication is this examination's purpose were in your knowledge base, producing the investigation, quality that its presence there creates for the senior engineers whose terminal fluency it underlies. Here is exactly what the command is, in the technical terms that make its operation comprehensible, rather than requiring the reader to discover the comprehension themselves after being told the command's name, without the explanation that transforms name knowledge into application knowledge. Here is why senior engineers know about it, and most junior developers do not, specifically in terms of the educational pathway, whose coverage decisions produce the knowledge gap, and the discovery pathway, whose operation distributes knowledge of the command to the subset of the developer population, whose circumstances include the specific exposures that the discovery pathway requires. Here's the complete capability scope of the command, covering the full range of the engineering workflows, whose transformation through the command's application produces the productivity improvements that this examination is claiming, with the concrete examples that make the transformation from the prior multi-command approach to the single command approach visible and immediately actionable. Here is how to start using it today, with the specific invocation patterns and option combinations whose mastery produces the immediate productivity improvement rather than the gradual capability development that learning a new tool through experimentation alone produces. Here is the deeper capability whose mastery rewards continued investment beyond the initial proficiency, whose achievement the immediate adoption section enables. And here is the honest assessment of why this command, whose value this examination is communicating as among the highest leverage pieces of Linux knowledge available, has not been communicated to you before today through the educational channels, whose purpose is preparing developers for the professional work whose performance this command improves. The command is Strace. If you have heard of Strace and moved past the name recognition to the complete operational understanding, whose possession allows daily application to the full range of engineering problems that Strace transforms from multi-hour investigations into multi-minute resolutions, then you are among the senior engineers whose daily use of the command this examination is documenting, and whose communication of its existence and its complete capability to the developers below them in the organizational hierarchy. This examination is replacing, if you have heard of Strace in passing, know it as something to do with system calls, and have a vague understanding that it is a debugging tool whose application to specific situations you have not been able to confidently identify, because the explanation that makes its application comprehensible was not provided alongside the names mentioned in whatever context introduced the name to you. Then you are precisely the developer for whom this examination exists, and whose reading of it will produce the capability understanding whose subsequent application will compound into the career-level productivity improvement that the daily use of Strace by engineers who know its complete capability scope represents. If you have never heard of Strace, then you are the developer whose educational pathway has most completely failed to communicate the high-leverage Linux capability whose existence is as consequential for professional Linux development and system administration as any other single piece of technical knowledge, and whose discovery through this examination, rather than through the years of accidental exposure that would otherwise have eventually produced it, represents the specific value that direct communication of systematically undercommunicated knowledge provides. Strace is the Linux system call tracer whose operation intercepts and records every system call that a running process makes, displaying each call with its arguments and its return value in real time as the process's execution produces them, creating a complete record of every interaction between the process whose execution you are tracing and the Linux kernel whose services the process's operation requires. System calls are the interface through which every process on a Linux system requests services from the kernel, including every file it opens, every network connection it makes, every process it creates, every signal it sends or receives, every memory allocation it requests, and every other interaction with the operating system infrastructure that the process's execution involves. Tracing the system calls that a process makes is therefore tracing the complete operational behavior of that process at the level of its kernel interactions, which is the level at which the operational behavior is expressed in the implementation independent terms that reveal what the process is actually doing, regardless of what the process's source code, documentation, or developer claims about its behavior describe. The specific engineering problem, whose solution through Strace's application demonstrates most immediately why senior engineers who know about it reach for it in situations where junior developers begin a different investigation approach, is the problem of the process that fails silently, producing no useful error message or producing an error message whose content does not identify the failure's cause with the specificity that directs the investigation toward the component whose malfunction produced the failure. Silent failures and uninformative error messages are among the most time-consuming debugging scenarios in professional engineering work because they require the developer to investigate the failure's cause without the signal that a useful error message would provide, using the indirect evidence that examining the process's configuration, the system's state, and the application's logs produces. The developer without knowledge of Strace approaches the silently failing process through a sequential investigation that examines the configuration files. The process should be reading, verifies the permissions of the directories the process should be accessing, checks the network connectivity to the services the process should be connecting to, reviews the application logs for entries that might indicate what the process was attempting when it failed, and progressively narrows the investigation through the accumulation of partial evidence, whose combination eventually identifies the failure's cause if the investigation is comprehensive enough, and the developer's patience holds through the hours that comprehensive investigation of a multi-component system's failure can require. The developer with knowledge of Strace approaches the silently failing process by running Strace against the process's execution, reading the system call trace whose output reveals exactly which file the process failed to open and why the open call returned an error, exactly which network system it was looking for the library when the load failed, and exactly which system resource the process was attempting to access when the failure that produced the silent exit occurred. The Strace output answers, in the first few seconds of examination, the question whose sequential investigation approach. The practical skill of reading Strace output is the skill of scanning the output for the -1 return values that indicate failures, and reading the context of each failure to understand which operation failed and why, which is the reading skill whose development transforms Strace from an information-dense curiosity into the most powerful debugging tool available in the Linux environment. The development of this reading skill requires the specific examples whose examination builds the pattern recognition that makes the navigation of Strace output as fluent as the navigation of any other structured output whose format familiarity develops through repeated reading. The file not found failure whose occurrence in Strace output reveals the specific path that a process was looking for a file at when the failure occurred is the Strace output pattern that demonstrates the tool's immediate practical value, most clearly because the file not found failure is among the most common failure types in Linux system administration and development, and because the silent file not found failure, where the process attempts to open a file at a specific path and fails, but produces no error message identifying the path it was looking for, is the failure type whose resolution through the sequential investigation approach is most time-consuming relative to its resolution through Strace. In Strace output, the file not found. Failure appears as an open at system call, whose first argument is the directory file descriptor whose value identifies the base directory for the path resolution, whose the process was attempting to open, and whose return value is -1 followed by anawent, which is the error name for the file, not found error, followed by the description, no such file or directory. Reading this line in the Strace output provides the complete information required to understand and resolve the failure, specifically the exact path the process was looking for when the failure occurred, whose knowledge directs the investigation immediately to whether the file exists at that path, whether the path is a configuration that can be corrected, or whether the missing file requires creation or installation. The permission-denied failure, whose occurrence in Strace output reveals which file the process was attempting to access and why the access was denied, is the second, most impactful Strace output pattern for daily engineering work. Because permission-related failures are the second most common failure type in Linux system administration, and because the permission-denied failure in the context of a process running with unexpected user privileges, running in a containerized environment with restricted file system access, or attempting to access a file whose permission configuration does not match the process's user identity produces the investigation whose resolution through Strace is immediate, and whose resolution without Strace requires the systematic examination of file permissions, user identities, and security module configurations, that the complete absence of information about which specific file access failed makes comprehensive rather than targeted. The connection refused failure, whose occurrence in Strace output reveals which network address and port the process was attempting to connect to when the connection failed, is the third critical Strace output pattern for daily engineering work. Because network connectivity failures are the third most common failure type in modern microservices and distributed systems development, and because the connection refused failure in the context of a process whose configuration the developer believes directs it to the correct service endpoint, but whose actual network behavior differs from the configured behavior, produces the Strace investigation that reveals whether the discrepancy between configured behavior and actual behavior is a configuration file parsing failure, An environment variable resolution failure, or the correct behavior of a process whose source code logic does not implement the configuration reading that the documentation describes. The strace option, whose application transforms the basic invocation from the tool for investigating a single process's system, calls into the tool for investigating the complete system call behavior of a process. And all of the child processes that the process creates during its execution is the follow forks option, whose specification through the -f flag enables the tracing of child processes as they are created by the traced parent process. The follow forks option is the option whose addition to the basic strace invocation is required for the correct investigation of failures and processes that delegate work to child processes, because the failure that the investigation is seeking may occur in a child process rather than in the parent process, and the basic invocation without the follow forks option traces only the parent process whose system call trace does not include the child process system calls where the failure occurs. The strace option, whose application transforms the output from the real-time stream that the basic invocation produces into a file-based record, whose examination after the traced process's completion allows the thorough analysis that real-time stream reading does not support, is the output file option, whose specification through the -o flag followed by the output fill. ePath directs the system call trace to the specified file rather than to the terminal. The output file option is the option whose use in production system investigations, where the trace process produces thousands of system calls, whose complete record requires file-based examination rather than terminal-based. Reading is the difference between a strace investigation that captures the complete system call record for thorough analysis and a strace investigation whose terminal-based output scrolls past the critical failure evidence before the investigator's reading speed can capture it. The strace option, whose application filters the system call trace to the specific system, calls whose relevance to the investigation makes them the signal whose extraction from the complete trace produces the focused output that the investigation requires without the background noise of the routine system. Calls that every process produces is the expression option, whose specification through the -e flag followed by the system call names or system call categories whose tracing is desired limits the strace output to the specified calls. The expression option, whose application to the file access investigation specifies the file access system call category through the trace. Equals file specification produces the strace output that contains only the file system operations, eliminating the memory management and signal handling system calls whose presence in the complete trace output is background noise rather than investigation signal for the file access investigation. The strace invocation that combines the follow forks option, the output file option, and the expression option to produce the focused, complete, file-based system call record that the thorough investigation of a complex process failure requires is the invocation that senior engineers compose fluently from the option combinations, whose mastery produces the immediately applicable investigation capability that this examination's adoption section is building through the specific examples, whose examination develops the compositional fluency, the complete invocation whose form is strace-f-o investigation. Output.txt-e trace equals file, followed by the command whose investigation is being conducted, produces the file-based record of every file system operation performed by the process and all of its child processes during the execution, whose investigation the strace application to the Docker container debugging scenario, whose frequency in modern development makes it among the most valuable applications. Of the command for the development engineer, whose workflow involves containerized application development, demonstrates the command's value in the context that the current development environment's dominant pattern creates as the daily investigation need. When a Docker container fails to start or produces unexpected behavior during startup, the container's logs frequently provide insufficient information to identify the failure's cause, because the containerization layer's isolation from the host system's diagnostic tools creates the investigation environment where the standard debugging approaches that work for host process debugging are unavailable within the container's isolated execution environment. Running strace against the container's entry point process from the host system using the process identification of the container's main process obtained through the Docker inspect command produces the system call trace that reveals the container's complete startup behavior, including the file accesses, the network connections, and the system resource requests, whose failure is producing the startup problem that the container's logs do not identify. The strace application to the performance investigation, whose productivity impact for the performance debugging engineering workflow is comparable to the productivity impact for the failure debugging workflow, demonstrates the command's value beyond the failure investigation context where its application is most immediately obvious. When an application's performance is degraded without obvious cause, the strace output with the timestamp option enabled through the -t flag or the relative timestamp option enabled through the -r flag provides the per system call timing information that identifies which system calls are consuming the execution time whose accumulation produces the performance degradation, directing the performance investigation immediately to the specific operation type whose performance is the problem, rather than requiring the broad performance profiling investigation that the absence of system call timing information necessitates. The honest assessment of why strace has not been taught to you through the educational channels, whose purpose is preparing developers for professional Linux engineering work, requires engaging with the specific character of the gap between the foundational Linux education that those channels provide and the professional engineering knowledge that professional Linux work requires. The foundational Linux education that courses, tutorials, and educational resources provide covers the command line navigation, the file system operations, the process management, the network configuration, and the shell scripting that constitute the knowledge base from which entry-level Linux work can begin. The professional engineering knowledge that makes the difference between entry-level proficiency and senior engineering capability includes the debugging and investigation tools like Strace, whose mastery represents the accumulated professional experience that transforms competent Linux users into expert Linux engineers. The educational gap between foundational knowledge and professional engineering knowledge is not a gap that exists because the professional engineering knowledge is genuinely more complex than the foundational knowledge whose acquisition the educational pathway prioritizes. Strace's basic application is not more complex than the application of the foundational command line tools that every Linux introduction covers. It is a gap that exists because the educational pathway's construction reflects the knowledge categories whose systematic organization into teachable units. The educational framework's creators found more tractable rather than the knowledge, categories whose professional impact most justifies their inclusion in the educational pathway, regardless of the organizational tractability that their inclusion requires. The command is strace. It is in your package manager. Install it with sudo apt install strace on Debian and Ubuntu systems, sudo dnf install strace on Fedora and Red Hat systems, and sudo pacman -s strace on Arch systems. Run it against the next failing process whose failure message tells you nothing. Read the output for the -1 return values. Find the ennuent that tells you which file it was looking for. Find the ACCUS that tells you which file it could not access. Find the econ refused that tells you which address it could not reach. And understand in the first 30 seconds of investigation what the sequential approach would have required an hour to reveal. Because that is what senior engineers have been doing, every day, for years. While the debugging sessions around them took 10 times longer, not because of superior intelligence, because of one command that nobody taught you until now. Open the terminal, type strace, and watch what happens to your debugging sessions. Because the gap between where you are now and where the senior engineers are was never as large as it looked. It was always the distance between not knowing this command and knowing it. That distance is now 0. Use it.